morning everybody, and let us continue our discussion on the guideways. In the last class we have seen that there are different type of guideway available, linear guideway, hydrostatic guideway and aerostatic guideway, and we have found that aerostatic guideway have the very low friction, and that is mainly useful for the micro machining or the very high precise motion applications. So, in that case let us continue further in this class. So, this was the last slide we have seen in the last class, and here what are the things which is good for the aerostatic, that it avoids the traditional bearing related problems of the friction wear and lubrication handling. If you see that earlier case, that where we are using hydrostatic part, there was one particular things you might have noticed, that it was a closed loop system, correct. So, it is a hydrostatic is a closed loop system. That means you have to recirculate the fluid. Correct. That means that here what we are doing, that we are actually not worried about the collecting the air again. Whatever air is coming from this particular bushing, it is going to disperse in the atmosphere, right. And that is not the case here, because here what you have to do, that you have to provide a lubricant handling system. It should be a fully closed loop circulating system. So, once you pass this liquid from this particular bearing, that it should be collected and then again it should be recirculated. So, this is more complex system compared to the air, because in the air you have to worry about supply only, not the what is going to happen after supply. But here in the aerostatic bearing you have to actually look after the supply also, and then how to collect those particular liquid, because you cannot actually spill all the oil after its usage. So, that is the big problem or very big difference between the two things, hydrostatic and the aerostatic guideway. And linear and friction and the wear, both things are more discussed about this both the things, but still we consider the aerostatic bearings have much less friction compared to the other cases. Right. So, this is the flat air bearing type of thing. So, here what is the thing here? So, these are the two ways. So, it is mostly done by the orifice type of or the porous media that restrict the meter the flow of the air, and that is called restriction orifice. Now, what is this restriction orifice? That you have you can see here that there are two things here, restriction orifice R1 and restriction gap, that is R2. And now you are providing the air supply from here, and this whole body is lifted on the base surface. So, this is the base and this is the body, correct. So, now you have to restrict or meter the flow of the air, right, because now once you provide a 60 Pascal per square inch PSI, then what is going to happen, that you do not know first that how much is the load coming from the top, right. So, that is the force or the load. Then depending on that you have to finalize that how much is the thickness required, air film thickness. Correct. So, if you want to maintain this particular air film, suppose we are considering air film thickness maintenance is considered 15 micron and your load is variable, then what you have to do, you have to actually do a restriction on the supply, or you have to meter the flow in such a way that even if there is a variation in the load, you always maintain the 50 micron by maintaining a particular pressure, because we know the what is the area available at this location. So, by area, force and the pressure calculation, we know that force equal to load upon area. So, in that particular case you can easily calculate that how much is the pressure required to maintain a particular film under a different loads. So, that is called the restriction orifice. So, this orifice will supply the air between the body and the base, so that you always maintain this particular part, then it will actually go away from this particular part, right. So, flow of pressurized air through the restriction is sufficient to match the flow through the gap. Now, what is happening, that we know that we are actually throwing everything away from this part, right, because we are not collecting anything. So, what we have to maintain? We have to maintain a balance between the two things. First thing is the flow of the pressurized air through the restriction, how much is the air is coming through this and how much it is passing through this gap, correct. So, if you consider this gap is very large, now consider these are the two surfaces, this is the one location and these are the two location, and you consider you are providing the same pressure P1, it is also P1, correct. So, here what is happening, here area is very large. So, what is going to happen, your load will be very low. So, you have more clearance. So, whatever is coming out of this thing, it is a large outgoing is large. So, here it is a less. So, here it is a more metered, that means more balanced thing. So, what we have to do, that we have to balance both the thing, how much we are putting this thing and how much it is passing through this particular gap. So, that is called the restriction of the gap, right. So, what is the restriction gap? It maintains the pressure under the bearing and supports the working load. So, we have two things here, that how much we are pressurizing or how much we are supplying, that is through the orifice that is supplying, and that means how much we are leaving it away. So, that is called the gap restriction. If the gap is more, what is going to happen, that your gap restriction, that means pressure will be very less here, because now area is increased. So, in that case, that is a big problem here. So, now if you press it little bit more, your area is reduced, now your pressure is increased. So, again it will balance the thing, that we have seen in the last that animation or that movie clip, where the if it is displacing vertically, then automatically air was maintaining that particular center line between the shaft and the bushing. So, that is why you need two restriction, one is the restriction in the gap and one is the restriction in the orifice, right. So, this restriction refers as a air bearing compensation, right. So, whenever there is a force, that means you have encountered two different type of forces, one is the thrust force and another is the side force, that is mostly going to happen in the milling machine or different type of micro machining operation. So, what we have to do, we have to compensate this particular bearing by restriction of this particular thing, orifice restriction and the gap restriction, and to optimize the bearing for the lift, load and the stiffness. Because now we know that if your load is variable, again you have to maintain both the things, because your objective is to get a uniform thickness of the particular air film throughout the operation, whether it is a static condition or the dynamic condition. Our objective is to keep this uniform or uniform film thickness, correct. So, that is the thing. Lift is also important, how much it is move upside down, and the stiffness is important, because it should not deform completely under a particular load. So, this whole thing is defined or it is considered in the bearing compensation, and for bearing compensation you have to pay attention to these two things, restriction orifice and the restriction gap, right. So, what are the two things? There are two ways you can supply the air through this particular part. So, this is one is called the through orifice and another called is the porous media. So, when you are talking about orifice media, that means air is supplied through a small number of precisely sized holes, and precisely flow rate control, very high pressure rate and high operating temperature range are there. So, what does it mean? That suppose you consider that this is your plate and then you are drilling some holes here, and this is the bottom surface, correct, and you are supplying air from this in such a way that air is passing through this side. So, this is called the orifice media type. That means, you are this water hole is there, that is you consider orifice, right. So, this is the way it is working in this particular case. So, what are the advantage? Advantage is precisely rate flow control, because now you know the diameter of this particular surface. So, whatever the hole you are drilling, you know the diameter of the hole, very high pressure is possible, because everything is solid things, correct. So, let me draw it again. Right. So, precisely controlled, that means you know the size of this, dimensions are known. Very high pressure rate is achieved, because now we know that this whole thing is a solid material, solid and strong material, and high operating temperature, because now temperature will not make much difference here, because this everything depends on the what is the coefficient of thermal expansion of this particular material. If you use very strong high strength material, then temperature is also not an issue. But what is the problem, that it damage not easily repaired. By chance if something happened that you are not able to maintain that film and there is a direct physical contact between the two surfaces, and then during most it will damage, and once it is damaged, at that time it is very difficult to repair those things. You have to actually replace only, repairing is mostly not possible because diameters are in micron level and it is precisely measured, and if the surface has some type of scoring effect or some type of scratching, then it will create a variable or the differential pressure gradient, and that creates a problem, and not good on mating surfaces with the gaps and cavities. Now, suppose your bottom surface is both things are not flat completely, bottom surface is something like this, then what is going to happen, again you are end up with the variable pressure, and calculation of that particular maintenance of that particular film is very difficult in this particular case, and that is the reason that orifice media type of flat air bearing is very difficult to use in particular application. But still this is the first type of air bearing which was developed, and still many applications this is still preferred because of this some of the advantages, because many times you will take care about this particular part by some type of gap sensing element or something sensor, then you actually this is the more versatile and more easy to use thing. Right. Another one is the porous media. So, now what is going to happen, that instead of those type of holes, right, so earlier we have seen that these are the orifice. Now, instead of orifice, what we are doing, we are using one type of porous media. So, there are different small holes available or some type of passage available. So, it is considered the porous material. Right. So, what is going to aid through a porous medium to ensure the uniform pressure. Now, you can consider that here that depends on the which are the location where you are providing the air supply at this location in this particular case, first case, correct. So, you know that if you measure pressure at this location it will be very high, but if you measure pressure at this location it will be less, because now there is no flow of the pressure. So, if you see this particular pressure profile here, it will be different, that we will see in the next slide, that what is going to happen depending on the location of this particular location of the orifice depend on the pressure grade. But here what is happening here, that you are getting a large amount of small holes because of the inherent porosity of the material. So, air will pass through this porosity, and at the end you may get a hundreds of holes through which you are getting a air supply, right. But here it is actually machine or manufactured thing, here it is a natural thing depending on the porosity of the material. So, at the end you may get thousands or hundreds of holes, but that is not possible here, because here you have to maintain the, you have to precisely tell the how many holes are required. So, that is the difference between the two things. What are the advantages? The large grooves on the mating surface do not greatly affect the performance, because now we know that there are different type of contacts. Now, if this thing is bending here, now suppose you are putting workpiece here, right, you are putting workpiece here, then load is uneven in this. So, this particular part will touch the surface, right. When it is touching, this is the only nozzle which is actually giving the compensation or the resistance to this particular compression, but this particular location will touch the surface. So, that is the problem in this type of cases. So, when it is tilting at that time, there is a problem in this particular case. So, this is going to happen, but your nozzle is here. So, it will not make much difference here, but the same thing happens here. What is going to happen? You have a hole on all the directions. So, even if it is a tilted, then this particular hole will be under more pressure. So, it will stabilize again. So, that is the advantage of using this particular part, and it accidental rough handling and touch down, it will not create more problem in this particular case, because it is naturally made this particular porous media, but here we have fabricated, it is a designer issue. So, what are the things problem? The mechanical strength is a big problem, because now we can see that if you make something. So, this is the 2 or 3 holes available, and we have this material where they have porous things, these are the porosities, right. So, strength is a big issue, because now how much pressure you are providing Here you can go with a high pressure, we know that high pressure is not a problem, but if you provide a high pressure here, what is going to happen, that this material is very weak in the strength, because this inherent porosity will make this material little bit weak, and when you are providing high pressure velocity of this particular oil, then what is going to happen, that this particular whatever porous things are there, it will try to merge with each and that will start deforming within the structure. So, mechanical strength is a big issue, you cannot actually go beyond a certain pressure limit, and that is not an issue here, everything depends on what material you are using. Exposed to the oil, because now this is a porous material, this is the machine component. By chance if accidentally it comes into contact with the oil here, then you can clean it. So, cleaning is not a big issue here, cleaning, but here it is a porous structure. Now, you can consider that if you are putting a sponge into the oil, completely extracting the oil from the sponge is very difficult, because you cannot extract every oil from this part, and that will create a problem. Oil or solvent whatever you are using, it will start creating a problem. So, cleaning of this particular thing is very difficult, cleaning is not possible. Room temperature is also important, because now it is very porous material, so its surface area is very high. Porous material, so temperature is sensitive, temperature sensitive. Right. So, it is better to operate at room temperature. If you want to operate at high temperature, what you have to do? You have to provide a localized temperature cover, so that you maintain that particular temperature throughout the operation. So, we can see here that some of the things are good for the porous media, some of the things are good for the orifice media also, but both have some of the disadvantages. So, depending on the application or where you want to use this particular thing has a different things. Now, you can see this is the profile of the pressure. So, this is the pressure, right. So, this is the orifice type, and we are putting 4 orifice only. Now, if you can see that these orifices are matching with this particular peak pressure, you can see that there is no material available, no space available, nothing is available. So, you are getting a variation in this particular part. Now, this is another thing, that you have a continuous slot here, and these are the orifice 1, 2, 3, and you can get a peak part here. Here only single is that the maximum pressure will be at this location, and then remaining part it is continuously decreasing, and this is another way of the orifice where you are getting a different profile, and this one is the porous part, right. In porous we know that holes are throughout because of the porosity, and you can see the how uniform is the pressure profile. So, this is what is required, because you do not want a non-uniform pressure profile on a workpiece surface, so that here the loading is uniform, and when the loading is uniform, you may not encounter some type of deformation type of things or the some type of alignment problems. So, this is the one of the good thing, but still it has limited by many things. So, it is up to the application engineer which one is the good for that particular application. Right. So, friction in aerostatic bearing. So, friction is always the heart of the precision positioning problem, because when attempting to initiate or stop the machine precisely, because where friction creates problem at 2 locations, that is when to initiate the motion, right. So, once one particular thing is at the rest, then you have to apply certain force, after that only it will move further in this direction, right. So, this is the force requirement and this is the displacement. So, it will not start from the 0, it will start from one particular location, unless you cross that particular limit, then only you will get the displacement, right. So, this is particular called the stiction. So, you need a minimum force to reduce, that is called static friction. So, you require minimum force to move a one particular object. So, for initiating something you need some force here, that is when you have a friction between the 2 contacting surface, and once it is in motion and you want to precisely stop at this location, then there is again one problem, because when it is in friction, after that you are not able to stop at one particular location, because you do not know that how much is the time required to stop that particular thing if there is a friction into consideration. right. So, this is the coefficient of friction on the log scale. You can consider that this is the plain bearing, whatever you are talking, friction of coefficient of friction is 0.1 around, this is the rolling bearing and this is the air bearing. You can see it is a very small or almost is a negligible coefficient of friction, and that is what is the advantage of using aerostatic bearing for a high precision applications, right. Static coefficient of friction is higher than the dynamic coefficient of friction in this particular case, because when it is in static condition we know that we can easily maintain that part, but when it is in moving the component at the time it will be little bit low in that case, but still it is on both the cases it is higher compared to the other type of bearings, but within this particular bearing static component is higher than the dynamic coefficient. Force to initiate motion and to maintain that motion. So, what is the advantage here? When this particular case happens here, so because of the friction what is happening, that whenever you are starting the motion here, that is what is we have seen here. So, this is the component and we are moving this thing. So, initially you need one force to move this particular component in one direction. So, once you initiate the motion, then you do not require same friction for continuing that motion. So, that is why it is written the static coefficient of friction is higher than the dynamic coefficient of friction, correct. So, here because of that you are getting a in single motion, single movement, or we can say same movement, we are getting two friction, that is called static friction and dynamic friction. Correct. So, both things are different, and this both, that is the problem when you are talking about the friction. So, that is the first thing is the force to initiate the motion, that is what is required, and second dynamic friction is the to maintain that particular motion. So, this both things are present when there is a friction present, and both things are different. But what is the advantage of air bearing? That it does not have difference between the static coefficient of friction or dynamic coefficient of friction. So, that is the reason this is the advantage of using this particular part, because we know that there is no direct or physical contact between the two surfaces, and when that is the thing that at that time you can easily start the component, because now we know that there is nothing in between these two, only air is flowing. So, your force to initiate the motion and maintain the motion both are same, right. So, if that is the case, what is going to, you will not encounter the stick slip issue, because if you see that particular thing, that this is the particular graph you maintain. Let me see if that graph is here, it is not there. So, what is happening here in this case, stick slip phenomena. So, this is the friction. So, when you start the motion at that time you will require some force, but as soon as you achieve this particular initiation of the motion, your force will decrease little bit, and then it will actually move in between these two, and then you will get a high variation in this particular part when you stop and slip. So, this is called stick and slip phenomena, that is mostly happen when you want to rotate something by your hand. If you consider your carriage, you want to rotate onto the when you want to penetrate your tool into the workpiece, and then you are going motion by a wheel, right. You have a handle here, circular handle, and then you are moving this thing, at that time you will feel the stick slip phenomena in the machining process, that is very common issue. Friction in air bearing is a function of the air shear from the motion. So, here also there is a friction, but that friction is not because of the thing, but because of the mechanical contact, but because of the air shear, because now we have one particular surface and there is a air supply between the surface, and this is the under surface of this car. How much is the shear of this air, that will create a friction, but that friction is still much lower than the friction achieved by the different type of other bearing surfaces, right. Another thing is the veer component of the friction we have seen. Now, what about the veer? Because veer has directly connection with the speed, acceleration, and the loading, right. If you increase the speed, your veer rate is high. If you increase acceleration, your veer rate is high, and if you increase your loading, again your veer rate is high, if there is a direct or the physical contact with the surfaces. but this thing will not create any problem on the air bearing life, because air bearings are behaving different way, because no physical contact, no direct wear component, and loading is also independent of that part, and acceleration you can achieve with a very high rate. So, for air bearing this particular thing is not a issue. So, wear is not a problem, because no coupled component or no physical contact of the surface. So, you are not getting this thing. The mode of wear in the air bearing is erosion. So, the cleanliness of air has the greatest effect. Now, this is the only way, but it can be reduced or it can be completely eliminated if you filter the air perfectly. So, this is what is happening. So, this is the air, and if some particles are here, this is the air film, and then air is moving here. So, particle will actually erode these surfaces, that is at the long time after usage, and that particular erosion is happen because of this presence of these particles. So, if you maintain the cleanliness of the air, most probably you will not encounter this type of problems, right. Air bearings are immune to conventional notion of wear and will perform exactly the same even after many years of usage. Now, see what is the advantage of using this thing, that when you are working with a contact type of roller bearing, and we have seen in the linear bearing video also, that if the 90% of the components are perfectly matching a condition, that is the 50 kilometer of total life, or they are reaching the one particular life where the 10% of the components are failed within that particular time. But still we can see that those type of things are easy to calculate also. But here what is happening, that these particular things, whatever variation you can do here, there is no physical contact or no wear. So, if you start using your air bearing today, and if you use air bearing after 10 years of usage, there will not be any type of problem, or there is no any type of performance related problem if you maintain the cleanliness of the air, correct. So, that is the biggest advantage of using air bearing, because it has a very high long life within a permissible limit of the operating condition. So, that is the very big things. None of the other bearings can give this type of advantage, right. Clean room application is important here, because now if you see, if you want to use any type of other bearing, consider the full contact bearing, because there is heat generation. So, heat will again create a problem when you are using in a clean room. So, let me tell you what is the clean room. So, clean room is the one of the specification where you can maintain the temperature, humidity, concentration or presence of particle, or presence of particles or dust, or you can maintain many different other things. So, if you maintain one particular limit, then there are some type of clean room lights. So, clean room requirement means clean room requirement 10,000, clean room 1,000, clean room 10, clean room 1. Higher is the rating, higher is more strict is the maintenance of this particular. So, if you are maintaining a particle presence within a volume like a 0.5 micron particles are present in a 1 meter by 1 meter area or something like that. So, in that case you are maintaining a perfect condition for different type of applications. So, that is called clean room, because here we know that only air is coming out of the system and it is completely filtered. So, you do not need any type, you will not get any type of problem from the foreign element, which may create a problem when you are using a other type of bearing. Even hydrostatic bearings also you have to create a complete closed loop, and spillage of the oil and other liquid will create a problem at the later stage. So, clean room applications mostly it is related to the IC fabrication, that is where you are making some type of integrated chips on the silicon surfaces, or some type of lithographic processes where you do machining. At that time it will create a great things here. Right. So, let me continue this stiffness of the bearing, air bearing in the last class. So, till now whatever we have discussed, those things are related to the air bearing, and we will continue this air bearing topic in the next class also. Thank you very much.